Perfect. Well, who would like to start us off this week?
I can. I don't have anything to report this week.
Okay, that was quick. Thanks, John. Perfect.
I can make it similar. It was holiday here Thursday, Friday, so it was a really short week. Not really.
So what did you do with your time off?
For once, not working and not touching the computer for a long weekend.
Congratulations. A wonderful way to spend a long weekend. Excellent. Thibaut.
Working, shockingly surprising.
Excellent.
You got another long review from Peter, eh? He's just not letting go.
Yeah, he just copy pasted some of his previous comments, saying we insist on some of them that we already reply, and we pretty much have the same answer to give him.
Good luck. That's all I have to offer there. Oh man. Devin, looks like you've got a couple points down. Would you like to go next?
Yeah, sure. So I guess, yeah, I'd sort of finished off a bit of the refactoring of examples in the tutorials, and Joe took a little bit of a look at it, and so it looks like we all came to consensus, and it's been merged in, so that makes me happy. That's off my plate. So we have good examples and tutorials organized on the website now. And then I started to put in a little bit of work towards that SimPEG EM1D. And I'm kind of at a point now where I have to make some, I think, important decisions. And I thought maybe I could use a bit of input from the group. So I'm really just thinking about the sources, the receivers, and the survey. And I've posted a link to basically a GitHub issue that's kind of summarized a few things. So anyone's welcome to go click on that and take a look. Or I could screen share if you guys prefer that, and I could kind of point at stuff while I talk about it. You guys want to do that?
Sure, go for it.
Sure. So right now, how things are organized in this, basically we're sort of assuming that the same source and receiver type is used for all data. So you'd never have any kind of mixed situation where you'd have like a vertical magnetic dipole source and you wanted to measure a vertical and a long line component. So because of this, it makes the simulation really fast, but it also means that the way it was set up right now is all of these properties that we would, define sources and receivers individually, like the dipole moment or the radius of the loop, that kind of stuff is all just being defined in a survey class. So there's no sources or receiver class. It's just all in the survey. And for this, it makes sense. But it's not really how we organize things in SimPEG. And we also have waveforms that are kind of in their own .pi. And so just, I guess the challenge is that we don't want to kind of have this be defining each source and receiver pair individually like we might do in SimPEG, because then we would just be looping over everything and the code isn't as fast. But at the same time, it's not really following the class structure of SimPEG. So before I went in and started changing too much stuff, I wanted to get some input. And I think it is possible to look through the list of sources and receivers and say, oh, okay, each source receiver, if they're using the same source, the same receiver, like let's kind of do all the computations at once. But yeah, I could use some input on that. So is everyone
I think the best person to be able to comment on this will be Sug, because that's really his
Yeah.
code, right?
Yeah, I was hoping he would be there.
And it was definitely geared towards airborne surveys, but probably needs to be generalized, I'm sure. Yeah.
But I guess in a way, does it? Because I feel people are going to be using this code specifically to try and quickly get through large airborne examples.
Yeah, but at some point, someone's going to ask if they can do a single large loop with multiple sounding. It's going to happen, right? So
Okay.
if we have to touch it, I would say let's generalize it so we can do any possible cases, and then the airborne is just one specific case of that. You know, I would think that would be the next way forward. There's no point at bringing it in as is if it's not, you know, if it can't do all the things that the other surveys are doing.
Yeah. Okay. So this is useful information to me. So without getting into lots of nitty-gritty details, do most people feel we really want this to follow the exact same class structure that we have with all of the rest of our parts of SimPEG, and to be able to do all of those things? Like completely generalizable, be able to have any combination of sources and receivers and input, and create a survey and be able to simulate data. Is that what we all want?
I'm not actually entirely sure, and I think that this is also something where we should get Soggy's input. I mean, because I think it is fine to have things that are fit for purpose. And like this is solving a real tangible problem right now. And so if we haven't yet encountered the case where somebody wants something different, I sort of hesitate to generalize before we actually have a new problem that we need to solve.
Yeah.
I mean, I think it's great if things are consistent where they can be with SimPEG, but I don't know if we need to introduce extra complexity in terms of sources and receivers if this really is just focused on airborne EM. And so maybe this is something to talk about with Soggy too, because what we could think about doing is maybe actually even renaming this. This is SimPEG airborne EM 1D, and like that is the problem that it solves. And then if down the road we need to adapt some things, that's fine, and we can generalize. But that's just one potential perspective.
Yeah, I mean, I do like the idea of being able to put in any combination of sources and receivers as an academic exercise. You know, if we're really trying to reach schools, universities, get them using this to simulate data and understand geophysics, it's really nice if you can just define a source and then say, oh, I want to measure the X, Y, and Z component and simulate it up and make a basic plot. But just like we did with the DC resistivity 1D, right? What Joe did to look and say, oh, I'm going to make this much faster because we're reusing a bunch of the fields for these dipoles, and it's just a superposition. We're just adding the effects. There could be something like that where it recognizes that, oh, I'm doing a standard airborne EM survey, and so I'm not going to loop over a bunch of stuff. I'm going to just do this all simultaneously. I think that there's a way that we could serve both purposes if we put in some work.
That's a really good point, Devin.
I guess I'm just kind of curious, like, what is the end goal of using the EM1D, like SimPEG EM1D? Like, what is its purpose? You know what I mean?
That's sort of the question that I'm asking right now. Is I really would like to know. To me it sounds like there are people that are very interested in using the stitched 1D for inversion of real data sets. They are interested in actually trying to invert large airborne EM data sets quickly, and they really want it to be as fast as possible and to solve problems that are as large as possible. And then there's also a space for academics and getting people to learn SimPEG with a simple problem that I don't want to neglect that audience.
I guess my question is,
there is, I think, another audience out there which is not perhaps as large as the airborne community, but certainly a number of ground-based surveys that are practical. I mean, these are being carried out, and they'll be carried out with a location of a transmitter and then multiple receivers that are offset from that. And sometimes both the transmitter orientation and the receiver orientations are altered to try to get different sensitivities. So I think there's an intermediate ground where there's still the potential for the use of this kind of code, even outside the airborne community, and not just relegated to teaching the fundamentals of electromagnetics.
Yeah, I've always had trouble trying to use 3D codes for some of these ground-based large loop surveys, just because the sensitivity, you're putting that source right on the ground, and those cells are really likely to change. I wonder if this could be something that might give you a result that's easier to get.
And always, I mean, one of the really good uses for the 1D algorithms is just for that forward modeling, a first pass inversion, just to help calibrate what the 3D results might be, and just to look at normalizations of the data. I mean, there's quite a few reasons for working with the 1D algorithm before you go to 3D, even though maybe your final inversion is going to be done in 3D.
Yeah, I would be very interested to play with the stitched version as well, EM, if possible. But that would be then for dipoles and not for loops. So I don't know how easy it is.
We actually have the kernel for loops as well. So you would be able to put in the actual,
cool.
Yeah, you'd only be able to go and predict the response at a point though. So I don't think there's a receiver class that would integrate the electric fields over the pathway of a receiver loop. But we do have loop sources, and we do have wire sources, I believe. I think you could make a loop with an arbitrary shape. Yeah, so that was basically it. Just wanted to have a plan before I put in lots of hours. But maybe I'll get a hold of Soggy and try and meet with him, and anyone else who's interested in providing any feedback, and then come up with a game plan. That's sort of where I'm at.
Thanks, Devin. Yeah, I'd be super interested in joining that conversation if the timing works. Yeah, but it sounds like, at least from this conversation, that folks are pretty supportive of generalizing it, which sounds great.
Okay, yep.
Yeah, so loop me in also on that, Devin, please.
Yeah, of course.
I guess my question is this something that will be imported into SimPEG, or is this something that will be using SimPEG? Like the main.
The intention is to bring this into SimPEG and add it in. Just all of the development right now is just being done independently, just I guess to keep things a little bit cleaner.
In that case, I would be, if it's meant to be brought into SimPEG, I would be very much in favor of keeping it more general.
Yeah, no, I think we're all on the same page. And then we just need to do something to be able to make it fast when the set of sources and receivers are the same, and it would be the same, same integral.
There's a little bit of compiled code in there, right?
There is.
Yeah, there's like some preset weights for doing numerical integration. I'd have to go and do a little bit of digging. I'm a bit rusty on the practical way that we solve it, but yeah.
I think
there's also a Fortran. There's a Fortran function that gets called as well.
Joe is referring to that. The preset weights are from the digital linear filters for the Hankel and Fourier transform, if I remember right. But Joe is referring to the bit from Fox. How is it called? Leon Fox. Yeah, the Fortran.
Yeah. So there's this RTE mode Fortran 90. And so it'll look for it, and if it doesn't find it, then it's actually it's written as well. But Yeah.
Thanks, Devin.
You're welcome.
Joe, would you like to take the floor?
Sure. So one of the first things I'd like to talk about is properties. You know, the class that we kind of use to do everything with. We finally got in touch with Franklin about the future of that about that package and what they're gonna be using it for, and it doesn't sound like it's gonna be really maintained much anymore. Updated, it'll just kind of like, if there's a few pull requests, they might pull them in and things like that. But I'm not sure if it'll be well supported moving forward. He did point us to another package that called Pydantic, yeah. Basically, I know we were talking about last week that we Python 3.5 and 3.6 and higher have this thing, you can annotate things with types, right? So to give users hints at expected inputs to functions and return values of function. It's part of the 3.5. Well, Pydantic takes that another step and actually will enforce and coerce variables into those expected types. So and it's something that it looks like it's very wide, like there's a lot of other people using it as well, outside of just this, and it can enforce a lot more things that properties cannot. Like it can enforce, validate calls to functions of things and not just class values. So if we're expecting a function to have a certain input, we can just say it on the function. Like we can define it as part of the function instead of like validating it inside of it. So it's just another method. I've been looking into that, and it seems like it could work for our purposes. So I was thinking about trying to switch as a first pass, attempting to do it with discretize and switch properties out of discretize and have it rely on the Pydantics instead, just to see what would happen and to see if we could make it work like that. That's something, if you guys want to play around with Pydantic, I would encourage you to do that. The only thing is that NumPy arrays are not explicitly supported, so I had to come up with a simple class that will expect a NumPy array, which is pretty important to us, right? We need things to be able to work with NumPy arrays. Yeah. So.
And what about just going back to setters and getters?
I mean, yeah, we could do that too. Also, part of this is like it might make the documentation a little bit easier to do NumPy docs. I haven't played with it that much yet, but like I said, it does a little bit more than getters and setters, and it's like one of those things. It's essentially just automating a bunch of the getters and setters, which we don't necessarily need to rewrite every single time. I mean, those are nice, but it also provides automated serialization to like dictionaries and to JSONs, which is something that we want.
And that'll really help.
Yeah.
Yeah, that'll really help with parallelization.
So that was one of the reasons for like at least using some sort of package that supported that. Other than that, I think we're about ready to merge simulation in today.
Yay.
I saw Sagi just posted another pull request on that, or to simulation to fix a bug in the IP simulator, IP for apparent chargeability on the 3D case. I'm not sure if it needs to come in just yet, but we can get that in later as well. But I'd like to focus on getting the simulation thing in, and then we can fix a few more bugs if they pop up.
Do you want to hit merge?
I guess so.
Okay, you got to screen share.
Can I do it?
Need a drum roll.
Oh man, here we go.
Woohoo.
Oh wait, we need somebody to approve it. I will approve it.
Yeah.
Have all the
Everybody
green check marks.
should have a beer or a champagne or something.
Absolutely.
No,
Actually, you know what? I don't think I can approve it because I started it. So Joe can approve it and
I
can
can approve it.
all the power.
Okay, look at this green button. Ready?
And
Yay!
Something else I can do?
Woohoo!
Ready?
yep.
No!
Excellent.
Go.
Wow.
It's in master.
Wow.
Congratulations, guys.
There.
That's super exciting. That's really exciting. Well, we'll get the blog out today and also start a discourse post.
Still need to tag master for release, but yep.
Yeah.
Cool.
Joe, thank you so much for getting this in. You were the one who pulled it over the finish line. It would have taken us years otherwise. So thanks to Joe. Excellent.
There we go.
I guess I was gonna. It's disappointing that John isn't here today because I was actually gonna ask about the status of the MT3D code. So I don't know if anyone knows that. Right now we've got the 3D MT branch, and then there's an MT, kind of like a finished MT 1D branch that is that's kind of off of that one. And so if I was hoping to kind of bring those things together and bring those in, but I'm not really sure what the status of MT 3D is.
We can.
Yeah, I haven't seen any pushes to that branch recently, though. So I'm assuming not too much.
Excellent.
But I guess, yeah, I'll have to go and look back through the commit history, because last I remembered we were trying to figure out how to do basically implement the boundary conditions and use the same approach that the UBC Fortran codes use. But I don't know if that ever got validated.
I'm not sure. I would have to expect that if anything, it might be worth it just to switch the branch. Like try to merge it into master now instead. And if you're comfortable with the EM1D or the 1D side of it, although I know at one point we did talk about getting it as part of GeoAna, like at least the machinery as part of GeoAna instead of, and then just using that in the 1D code.
Well, I think I guess I didn't branch directly off of simulation. I branched off of the 3D MT development. So if I merge mine in, then it will also be merging kind of an unfinished 3D MT.
Yeah, maybe. If you might be able to rebase it or something. I'll figure it out.
Okay, it's stuff for next week.
Absolutely. So I've got a couple updates. First, I want to thank folks for giving some feedback and input on the blog. If you have any last words, you can get them in today, and then we'll get it posted probably by the end of the day or so. And I'll start a discourse post and just kind of send that around. And I guess one request that I would have is if folks can just kind of keep an eye on discourse, especially after this release, because I think we're going to get a lot of questions about upgrading and things like that, which is great. And so if we can all sort of keep a pulse and contribute where we can, that'll reduce load on any one person. I've also been getting started on the transform tutorial. So a big thanks to Soggy, who's already come up with and run sort of the 2D DC and IP inversions. But I started sketching together a notebook, and I would actually appreciate just thoughts on sort of my general flow. I'll show you. So I dropped the GitHub link just into the notes. I'll just show you that right now. I don't have my environment set up to actually run this. Okay. Let's see. Can you all see that? Yeah? Okay. So what I was basically thinking, oh wait, my screen sharing is paused. Why is it paused? Okay. So my basic thinking is I really want to go from sort of square one with this. And I know Devin's done lots in the tutorial, so I'm going to be pulling lots of your text in here. But basically I was thinking is let's just start directly from the data file. So here's the data file we're going to work with. Let's actually just look at what that data file is. And we actually run the notebook. It of course like shortens this, but it's still helpful, I think, to actually get a sense of like, this is what we're starting with. And then go in and actually, I know we've got these utilities, but I actually thought for a tutorial, it might be constructive to actually, let's just go in and let's read this file. So here's how we're going to read it. I get back a dictionary that has these things. And then from here, what I'm going to do is actually construct now a SimPEG survey. So I know we've got utilities to do this, but I thought that, you know, starting from I have a data file and I want to invert it is kind of a good framing for this. So what this code sort of, or what this read-in does is very similar actually to what the utility does. I removed a few if statements and things like that that work for more general functions. And this is like, this will read in data from Century, and that's probably it. And that's fine, I think.
But do you mention the utilities that could do similar things in a comment?
I will do that. I need to actually check that they would actually read in this file. Because this data file is a bit, it's the older UBC version, and I don't actually know if we have encountered that before in any of the other examples that we've done. Yeah, so I don't know, do folks think that that is like a reasonable thing to do, or would you rather just see like, we've got a utility to do this, let's focus on SimPEG?
I like it.
Okay.
I like the idea of knowing what's happening with each little piece, and then it's really good to mention that, yeah, we do have utilities, but we really just want to show what things are doing. It's like a little glimpse under the hood.
Yeah, that's kind of what I was thinking, is not to go like into too many details where it's not necessary, but basically like try and not use too many utility functions and things like that, but actually like just work mostly with the core framework. I also built a, go ahead.
Oh, sorry. I was gonna say, like, when Sarah was at like the visiting professor from Belgium, when she was at UBC, like, even though we had utils to import data, it took her a long time to get her data in and being able to invert. So I think this is great what you did here, and that we definitely, I agree with Devon, like we need that in the tutorial. And I will even suggest like contact Sarah and poke her to like if she can give you some input on that, because she has now a lot of user experience with SimPEG and loading specific data sets in.
Thanks, Thibaut. That's a great point.
Yeah, and ultimately, I'd actually like to be developing tutorials like that. So I've got some plans to make tutorials for imaging fields, and then some for, you know, inputting and outputting data in the future. Maybe not immediately, but yeah, that would be good to have.
Excellent. Okay. So where I'm at right now, this won't show up in here, but when I plotted this pseudo section at first, I thought it was a strange looking pseudo section. Just the geometry is a bit unusual. So I actually went in and wrote up a little function to plot a widget that actually shows us how this one for this specific survey was built, which was constructive, because at first I actually wondered if there was a bug in the way that we were calculating all the midpoints and stuff. There's no bugs. It was just different geometry. But then go through now the forward simulations and inversions. So I'll take a look at what Sagi did there and bring in some of his work in that sense. So that'll take us through the 2D inversion. Let me stop sharing my screen. We have 3 hours for this. So it's a fair bit of time, but we do need to have a break because folks, well, I certainly wouldn't want to sit in front of my computer screen for 3 hours listening to somebody drone on. So we need to have a bit of a break. So we have the Sentry data. We've also got the data from Raglan, so we can potentially also do a potential fields inversion. So Dom, I might loop you in on that one if you're game to even just hack together a first pass notebook with me. That would be awesome. And I think that's probably plenty.
Again, I would say just kind of, I mean, a lot of the stuff that Devin did, just download the notebook from there and use that as a starting point.
Yeah. That was the plan.
Hit the button that says download as IPy notebook.
Excellent, will do. What else? I lost track of the notes. Oh yeah, and then with that, there's been a few issues that I have sort of dug up and just found with the DC with namings and things like that, is like plot pseudo section, all this sorts of stuff. So I started a branch, I think called tutorials transform or simulation transform or something like that, to start addressing some of these things. But I put the link, sorry, let me find the notes again. I put links to 2 issues just with respect to how classes are instantiated. And so Joe's chimed in, and if anyone else wants to take a look and add your 2 cents, that would be great. And I'll just sort of plug away on some of those things, and hopefully we can actually ideally get this merged like before the tutorial, so that we can actually get it deployed on CondaForge, so that if folks want to be downloading this and running it locally, we won't run into any issues. So I'll try and keep that pull request pretty tightly scoped. Yeah, so that's basically it from me. Doug, oh, go ahead, Joe.
Did you want to talk about black?
Oh yes, good point. So we put black on SimPEG. Default for now. We can update the settings if we want later on. I appreciated your point, Dieter, about the documentation, especially. We decided not to do anything right now because our documentation is kind of a mess, and so we need to fix that. So we'll get that in there. But right now, the way that it's set up is I've actually, for developers, you can actually install what's called a pre-commit hook. So what we can do is actually, let's maybe walk through this. I was thinking of having a demo, but yeah. So there's 2 things you need installed. Let me actually pull up that pull request. Joe, do you have the link handy, or?
Which the simulation pull request, or
the black one?
It's 879.
Okay, found it. So let me just reshare my screen here. Okay, so what you can do is we've installed a pre-commit hook. So actually, if you see, let me see if the file's at the top. Yeah, so there's this file here called pre-commit config.yaml, and all it's going to do is it's going to run black using Python 3.7. So if you have Python 3.7 installed, what you can do inside of the SimPEG, inside of the base, like inside of the root directory for SimPEG, if you do conda install pre-commit and black, so those are the 2 dependencies that we need. And then if you do pre-commit install, what it'll do is before you actually commit code, it'll check if black has run. If not, it'll run black, and then tell you commit again. So actually, let me see if we can do
one thing. Pre-commit, I don't think it's on the regular Conda stack, but it is on CondaForge.
Okay, so what I'm gonna do is just create. So I'm just gonna check out a temporary branch. Oops. Okay, and then in SimPEG, so let's take a look here. Okay, so I've got SimPEG here. Sorry, this is too big for my screen. Okay, so let's just go do something like this. So now I've got a long line and I've saved that. And so what I'm gonna do is if I do, sorry, that's a bit bigger now. Can you guys see that okay?
It's still good.
Okay, so if I do a git status, I can see that I made an update to static utils. So I can add that. And then what I'm gonna do is do git commit -m and say I updated static utils. And so right now, it's before it actually does that, it's going to check if black has run. That's interesting. Huh.
Yeah.
I think it has problems with some comments, right? So maybe do it with code rather than with a comment.
Yeah, let's try that again. That's super interesting. Okay. Okay, so that's what I expected to see. So that's a funny thing in black. Anyways, so this is the hook that's running and it's saying it failed because I had basically this line here. And then it should have actually gone and reformatted it and then say all done. So if I refresh that.
Yeah, I think it's just that it's a long string and it didn't break it up.
Yeah, so it didn't break it up. It's supposed to break it up. Interesting. So learning things about black. But anyways, so it did reformat it, and we can now see that we need to actually stage that again. And then I should be able to actually commit it, and it'll go through just fine. So that's kind of what that looks like. I mean, that's interesting to see that that didn't behave actually as what I expected. So that's something to look into. But what's nice is then you don't have to manually run black and you don't have to actually remember to sort of do the formatting, is that this will just take care of it for you. So give it a try. And if you run into any issues, feel free to ping Joe and I. But hopefully this will actually just kind of streamline the formatting side of things so that we don't have to ping folks to say, can you please run black on your PR before we review it.
So what kinds of things is it, are you hoping that it will catch in particular by using this?
So what it should do, and so it should have actually split up this string, but it does things like using double quotes instead of single quotes. It's opinionated on where brackets are. So here the open and close brackets are on the same, like the bracket closes on the same level as the line started. It should make sure that line, like comments or code doesn't go too far off to the right. So there's a line length of 88 is what black uses by default. So it's basically just like, and it also
consistency. It's a lot about consistency.
Yeah.
Yeah.
And it would make those changes and then notify you what it has done, or it just makes those changes and said, okay, I've made changes and you're good to go.
So it'll notify you with what's done. So here, if I run black on the whole repository, this might take a moment, it'll actually come back with any files that it's gone in and changed. So here, it didn't change anything, but if I were to change, for example, these quotes to single quotes, then this should come back and tell me that it will have changed this file. So it says it reformatted static utils. And then I can see here, it now went back to double quotes.
And this all works as well, like with source. I tried it with source tree last night when I was playing with it, and it works just as well with that. Do the same steps instead of typing Git, you can use source tree.
Okay, yeah, because I like to use source tree. So then, yeah, I guess how does that work with source tree? I make changes to some files. I want to commit, and then how does it invoke the changes, or how does it inform me that it's done so?
Here, let me show you. I can do that.
Awesome.
Hi guys, I need to get going. I'll talk to you later. Have a good day.
Yeah.
Bye.
Dom, so are you and Thibaut and I, can we have a small discussion later today or something?
Yeah, we can. Yeah.
Be nice just to get that paper off.
Yeah, I don't really think that you need my help. Thibaut, ping me if you need help. But yeah.
Okay, I'll get together then with Thibaut after, and we'll see where we are. Okay.
Sounds good. Bye.
Okay. I can show you really quick what it does with that. Share source tree here. Okay, so I'll make a branch. In that branch, I will make a change that I know is going to be bad, or I'll make an addition, let's say. I made a change in the init script, right?
Mm-hmm.
So this is something that should be, you can see the change there. So I'm going to go stage it, right? Commit. It gave me an error, right? Because I already did the part where, okay, you did pre-commit install and everything. So it said,
oh, right. Okay, yeah. So you did a pre-commit install of black, which means that GitHub knows. So
it knows that it's supposed to run it. Git knows. So this thing is using Git, right? So Git knows to do it.
So then, yeah, through the Git command prompt, I need to set up black, basically.
Yeah, whatever. Just do those few steps that Lindsay had on that pull request, but it does that. So okay, errors, and then it changed again.
Yeah. Okay. Do you mind posting that somewhere? It's like open the Git command prompt and then the 2 lines that you typed in.
I'll drop the links to the pull request into the meeting notes and into the Slack or into the.
Oh. Sweet. Yeah. I mean, I played around with trying to get this, and I first wanted to try and get a linter for Python, but that didn't really work out super well. I kind of liked working with the linter. Does that seem like it would be possible? Because then you can kind of get into the habit of writing the code properly as you're writing it, and really kind of not have to have black check it after the fact.
Well, I mean, I've got a linter in my editor as I'm moving, and I use Atom as my editor, but I've got a linter within there, and it notifies me when something's not going to be good.
Oh, okay. Yeah, I've been using Sublime Text, but I tried to get it set up, and it really wasn't as easy as they've done some stuff in Sublime on how you would set up a linter that's completely different from how we figured it out before. I was just wondering if somebody played around with it, but this seems fine.
Okay, I think that's basically it. Joe, is there anything else I should be?
I don't remember. I can't think of anything else.
I have a question because you mentioned the discourse with the new pull request, but I think there are integrations for Slack. Did you ever look into that? So that discourse will be posted on Slack.
That is a good point.
A quick Google brought me a post from 2016, so I guess it is still available, hopefully.
Okay, cool. Yeah, we should try that.
That might help to give a bit more visibility to the discourse topics.
Thanks, Peter. Yeah, that's a great point. Doug, did you have anything you wanted to chat about?
Nope.
Sounds good. Anything else folks want to bring up?
Nope.
Okay. Well, congrats again. Thanks again, Joe. Brought us over the finish line. I'm really excited about this. So it's a good week.
Yeah, really cool.
Yep, congratulations, guys. That's great. That's wonderful.
All right. Well, on that note, enjoy the rest of your day.
See ya.
Bye-bye, everyone.